am going to show you a quick example of what can come up in an exam question so that you can see. Generally in A-level maths, there will be about 10 questions in your C1 paper. Now that doesn't mean just one quick question, two quick questions. Each question goes into several different parts. So question 1 might have a part A, part B, part C, and a part D. And generally the A-level syllabus is quite nice because it leads you through questions quite nicely with these individual sections. So for example, you may potentially get a module like a question like this as part A, where you get, hang on, let's see if I can do this quite right. No, it's not going to let me write. Hang on. Okay, so I'm going to try and do this. I'm going to try and draw it big so you can see what I'm doing. And okay, let's have a go at this, right? Oh dear, that's meant to be a 6. I'd say this is definitely the funnest part of the session, I think. I hope I'm providing you all with a bit of entertainment as well as information about mathematics. There we go, 6x plus 8 over 4. Now the main reason why this is an A-level mathematics is because it really does identify individuals who are good mathematicians and going to survive the A-level topic, and those of you who may not understand the true background behind what you are learning at GCSE. This is where a lot of you who've learnt things at GCSE are going to find it very challenging. If I asked you to simplify this expression, i.e. write it in a nicer way, I can imagine that a lot of students who do not quite appreciate mathematics that they see wanting to cancel out this 4 down here with the 8 up there and writing a 2. Now the reason this does not work is because you're telling me that that 4 and that 8 can be isolated and cancelled out with no consideration for the 6x up here. However, that would give you 6x plus 2, which is not the equivalent of what you see on the screen at the moment. In order to cancel out any algebraic part or numerical part of an expression, you have to ensure that there are common factors that are being deleted. So, the top of this equation, which is a linear expression, it's linear because there are no powers higher than x to the power of 1, can be written by factorising out the number 2. So I can pull a 2 out of the 6x and I can pull out a 2 from the 8 over there. So you get 2, and then in brackets what you have left over is 3x plus 4. And underneath, the 4 still remains. Now here I've got a far safer example to look at. Here I could have made a silly mistake, deleting the 4 and the 8, but because we spotted that there was a common factor within the 2 at the top, we can rewrite it like this, and now you are allowed to cancel that 2 and that 4. Not this 4 and this 4, because once again this is still separated. Here, that 2 impacts everything that's in the bracket. It's 2 times all of this. So that 2 can now be cancelled with the 4 to simplify the expression. So we can say bye-bye to this. And divide that 4 by 2 as well to give us a 2 remaining. So finally, for this particular question, my final simplified answer would be 3x. I'm getting a little bit better now, aren't I? Plus, I think I spoke too soon. 3x, yeah I did, plus 4 over 2. Now this particular example is quite a nice one. It was a linear expression that they were asking you to cancel it down and simplify it. This would only be worth possibly just 1 mark in your A-level examination. And most of you can appreciate that because it could appear in your GCSE as well quite happily. However, in your GCSE, it would probably be worth about 3 marks because there are clearly 3 different steps you're doing. First is to recognise that something can be factorised. The second is to factorise out the content, which is that 2 there. And the third would be to cancel it down and write down the simplified answer. However, in A-level mathematics, they assume what you have learnt at GCSE is a given. So they will not award you extra marks for things that you ought to be able to do at the end of year 11. Let's have a look at something that's slightly more complex than that. Let's have a look at an algebraic expression which involves quadratics. So let's give you one like this, and this is more likely a very real example question that you might get up. I think it's from 2004 or 2006. I can't remember where I've got this question from. There you go. It's x squared plus 3x minus 10. Do you like my 10? I think that's quite, oh wow, that's a big line as well. Over x squared minus 25. Okay. So you've got x squared plus 3x minus 10 over x squared minus 25. And once again, the same question is applied here. Simplify this algebraic expression as fully as possible. Now, for those of you who've been aiming to get an A or an A star at IGCSE or GCSE, should automatically recognise that we have 2 quadratic equations written on the screen. For those of you who do not spot that immediately, the best thing about this module in particular is that they actually do teach you how to factorise quadratics once again in C1. So again, a lot of C1 is revision. However, if you do make the effort to revise what you've learnt at GCSE, you're going to find C1 very easy, and particularly this chapter will be wonderful, a nice little breeze through. So let's have a look at the top line here. You've got x squared plus 3x minus 10. That minus 10 tells you that one of your numbers has got to be negative in one of the brackets that you're factorising with, and the other number has got to be a positive number, because the plus in the middle of one bracket and a minus in the middle of the other bracket will create the minus that we see here. Then you need to consider 2 numbers that will give you an answer of plus 3x when they are added together. The 2 numbers here are going to be 5 and 2, because 5 and 2 make up the 10 quite comfortably when you multiply them together. And they add together to make up the 3. So x here and a 5 as well. Now the key here is to make sure that your plus and minus are in the correct place. We want to make a positive 3x. So you want the final result when adding these 2 numbers to be positive. That means that the 5 has got to be positive and the 2 has got to be negative. So if you were to take a little bit of time and expand this out, multiply using FOIL, or some of you might use a box method, which I'll discuss later on in one of our sessions if we do need to go through that. If you multiply that out, you get x squared plus 3x minus 10, which is what we had before. If you are checking your work whilst during the examination, I would advise multiplying out things like this just to ensure that you haven't made a mistake. Now that will all be over another quadratic here. Now this, in your GCSE, is an AA star question, x squared minus 25. If you're asked to factorise this, they are aiming to test whether you are of an ability of a student who is an A or an A star grade student. The method that most people will know when seeing this is something called the difference of 2 squares. You've got x squared, which is a square number, take away 25, which is also a square number, 5 squared. So when you notice that it's a difference of 2 squares, you should know straight away that that is factorised into x minus 5 as one of the brackets, and the other bracket is x plus 5. Now, if I ask you to have a look at what I've written up on the screen now, I hope that most of you will notice something that's very important here. And it gives me, if I was a student, give me a little bit of glee because I know I've done something right. You can see that you've got an x plus 5 on the top in the numerator, and you have an x plus 5 in the denominator at the bottom. Now, if you do not see this when you factorise 2 quadratics the way I have, and if you do not see any common factors at the top and the bottom of your quadratic and your expression, this is where I would stop and think, hang on a second, maybe I've made a mistake. Because the idea is that you want to simplify the expression. So hopefully by factorising both of them, you'll notice that there's something that you can delete from the top and the bottom, that you can cancel from the top and the bottom. So here I can say bye-bye to that, bye-bye. And I can cancel out the denominator as well. And I've got something far more simple than the complexity that I had earlier on. So I've created 2 linear expressions, one over the other. So x minus 2 on the top. Oh, I'm going to write it underneath, actually, it might be far simpler. So you've got from the top, x minus 2. And underneath, x minus 5. And this is exactly the same as the complex example from above. It's exactly the same as writing 2 quadratic expressions above each other. It's exactly the same as that, just written in a far simpler way. X minus 2 over x minus 5, like that. And that would be your final answer. Now, in A-level mathematics, because you actually get taught how to factorise these expressions, you'll get awarded marks for factorising that correctly. So you get 1 mark for the top. You would also get another mark for factorising the bottom appropriately, and then a 3rd mark for cancelling out those 2. Because it's addressed specifically in your A-level modules as something that they want to teach you, they will award you marks. Whereas the question that we did a minute ago you would not be given an extra mark for it because it isn't directly addressed in your A-level syllabus. Now, I hope that gives you a little idea as to the startup of your Core 1 module. There are lots of other modules within topics within that module that you'll have revised before, that you'll have met in your GCSE. For example, inequalities, you'll meet indices, so things like 27 over 64 to the power of 2/3, 27 over 64 to the power of 2/3. Again, that is an A-star topic from a lot of GCSE syllabi, but that does come up in your A-level, and again, they do teach you that from scratch. A lot of the A-star topics in your GCSE will be revisited in A-level C1 and C2. However, they will be taught as if you've never met them before, because several GCSE boards do not actually cover those modules at all. I'm going to show you one final thing